In this experiment, you'll use the solution you standardized in the last lab to determine the concentration of 3 acids: hydrochloric acid, acetic acid, and phosphoric acid. The hydrochloric acid and acetic acid titration curves will look similar to the KHP titration curve that you performed last time. Each of those acids are monoprotic, which means they only have one acidic hydrogen. But phosphoric acid is a triprotic acid. That is, it can lose up to 3 protons, 3 hydrogen ions. And this means that its titration curve will have 3 equivalence points. You'll remove the first hydrogen ion off of all of the phosphoric acid. Then you'll remove the second proton. Then you'll remove the third proton. Now, you're also going to perform 3 titrations for each acid. So you have 3 determinations of the equivalence point for hydrochloric acid and for acetic acid, but you'll have 9 determinations of equivalence points for phosphoric acid. Now let's talk safety. The hydrochloric acid and sodium hydroxide are both extremely corrosive to human tissue. Clean up any spills immediately, and if any touches your skin, wash the affected area immediately. Acetic acid is the active ingredient in vinegar. However, the concentration that we're using is significantly higher than the concentration in the vinegar that you go buy at the store, and consequently, it's significantly more dangerous to you. Like the hydrochloric acid, acetic acid is corrosive to human tissue. It'll also burn if it's at a high enough concentration, so you need to keep it away from any heat sources. In addition, it's also volatile. Not only does it stink pretty bad, but as I mentioned, it'll react with your mucous membrane in your nose, so you really don't want to breathe it in. Keep the concentrated solutions in the hood. In addition, phosphoric acid is also corrosive to human tissue. Clean up any spills immediately, and if any touches your skin, wash the affected area immediately.